Hey guys, hello everyone and welcome to the channel and welcome to one another video on single short video series. In this series we are taking topics and we are trying to cover it up in a single video so that you can revise the topic in a single shot. Today the topic of discussion in this video is going to be electrochemistry. We have already covered nuclear chemistry, polymer chemistry and we have also done surface chemistry. So in case if you have not watched the previous videos, the link is there in the description of this video. Do check out the playlist to watch the other videos as well. For this particular video, I would like to thank Karthik for providing all the slides, for making them and giving his time on this. Thank you so much, Karthik. A big shout out to you. One more very important thing, that if you are new to this channel and if you have not subscribed the channel yet, please do consider subscribing it. I'll be bringing more chapters and more topics before the CSIR net exam in the form of single short videos. Also, we'll be having some question series as well. So do subscribe the channel. Now, without wasting any time, let's continue with our video. Alright, so what are the basic things which we have to study in electrochemistry? The first thing which you have to study is basics of conductance. Then you have to study cells and Nernst equation and numericals related to that. After that comes electrochemical series and the trends related to that, and then comes some advanced topics including your mean anionic activity and Debye Huckel rule and all. So what is conductance? So conductance basically is flow of electrons through the material. That's what is called conductance. It's opposite or it's reciprocal of resistance, and that's why it is also given by 1 by R. So conductance is denoted by G, and that is equals to 1 by R, where R is equals to rho L upon A, where rho is nothing but resistivity and or called as a specific resistivity as well. L is the length of your wire and or the conductor, and A is the cross sectional area. L upon A combinedly is called as cell constant. If you use the same equation, that is R is equals to rho L upon A, and you make this as 1 upon R is equals to 1 upon rho into A upon L, or you can call it as 1 upon rho is equals to 1 upon R into L upon A. Now this formula converts into a new formula which says that 1 upon rho is denoted as specific conductance, denoted by kappa. Okay, so this can be denoted as kappa, and that is going to be equal to 1 upon R, which is nothing but equal to conductance. So that can be given as G, and L upon A, as I already mentioned, that it is nothing but cell constant. So you will have another formula, that is kappa is equals to G into cell constant. All right. So this is an important formula. From here, 2 marker questions are generally asked in CSIR net exam. There are 3 types of conductance majorly. One is called molar conductance, the another is a specific conductance, and one more is there, that is called equivalent conductance. Now, the specific conductance is the conductance of the solution of definite dilution enclosed in the cell having 2 electrodes of unit area separated by 1 centimeter apart. So that are the specific things which have been made for the cell, and that's why the conductance which you get from there is called a specific conductance. Whereas equivalent conductance is the conductance of the ions produced by 1 gram equivalent of the electrolyte. In case of molar conductance, the conductance of ion produced by ionization of 1 gram mole of the electrolyte. Okay, so molar means you have to take the concentration in the form of molarity. Equivalent conductance, you have to take concentration in terms of normality. Now, there is a relationship between them. So, lambda EQ, that is equivalent conductance, is equals to kappa into 1000 upon C, where C is the concentration in grams equivalent per liter. Okay, so equivalent grams per liter. Molar conductance is equals to kappa into 1000 upon C, where C will be the concentration in moles per liter. You have one more equation which relates your equivalent conductance with the molar conductance, and that is like lambda EQ is equals to lambda M upon NZ, where N is the number of cations or the ions, and Z is the charge of the cation, and the similar for the anion. That means if you are doing it for anion, so it will be number of anions and the charge of anion. All right. So this formula is important, where it relates if you are having value of equivalent conductance. So you can find out the value of molar conductance by putting it in this particular formula. The same formula repeats itself here as well with an example. So lambda EQ is equals to 1 upon N plus into Z plus into lambda M. I already gave you in the previous slide. So N plus is number of cations, Z plus is charge on the cation. For example, if you have Al2SO4 whole thrice, so here if you break it, so it will form 2 moles of Al plus 3, whereas 3 moles of SO4 2 minus. So when you are calculating for cation, so the number of cations are 2, so the value of N will be 2, whereas the charge of cation will be 3. So that's why Z is going to be 3. And the formula will be lambda Eq is equals to 1 upon 2 into 3 into lambda M of Al2SO4, or lambda Eq is equals to 1 upon 6 lambda M. So that's how you can simply relate the things. I hope you understood. Next thing is Kohlrausch law. The statement for the Kohlrausch law says that at the time of infinite dilution, the molar conductance of an electrolyte can be expressed as the sum of contribution for its individual ions, or you can say that the molar conductance at the infinite dilution is equals to the sum of molar conductance of the respective ions, right? V plus and V minus over here denotes the number of cations and anions per formula unit of the electrolyte. If you want to take it as an example, then the molar conductivity of HCl at infinite dilution can be represented as like the molar conductivity at infinite dilution of HCl is equals to VH plus lambda naught H plus and VCl minus lambda naught Cl minus. Now for HCl, VH plus is also 1 and VCl minus is also 1, because the number of cations and anions formed are 1 and 1. So you can substitute the values, and that's the formula which you are going to get for this. There are two more forms of Kohlrausch equation, and that is like lambda m is equals to lambda naught m minus k under root c. Okay, so this lambda infinite m or lambda naught m are same thing. That tells you the molar conductivity at infinite dilution, and this formula is only for strong electrolytes with very low concentration. All right, lambda eq is equals to lambda naught eq minus k under root c. Again, the same formula in terms of equivalent conductance. Degree of dissociation is denoted by alpha, and it is calculated as lambda m upon lambda naught m. Dissociation constant can be calculated as k is equals to c alpha square divided by 1 minus alpha. For weak electrolyte, k is equals to c alpha square. So that's the formula which you can use. Ostwald dilution law can be given as 1 upon lambda m is equals to 1 upon lambda naught m plus lambda m into c upon k naught into lambda naught m whole square, where lambda m is the molar conductivity at a particular dilution, whereas lambda naught m is molar conductivity at infinite dilution. Okay, so now you can plot this graph while taking 1 upon lambda m at y axis and you can take lambda m into c in the x axis. So this equation becomes of the form y is equals to mx plus c, considering that the intercept will come up 1 upon lambda naught m and the slope is going to come up 1 upon k naught and lambda naught m whole square. So that's the value which you get from the Ostwald dilution law. Transport number of the cation and anion can be calculated by the formula T plus minus is equals to mu plus minus divided by mu plus plus mu minus, where plus is for cation, minus is for anion, and mu is the mobility of that ion. Okay, and T plus plus T minus is equals to 1. So how to use this formula? If you are calculating, let's say, a transport number of cation only, we will write down T plus is equals to mu plus divided by mu plus plus mu minus. That is going to be the formula to calculate the transport number for cation. In the similar way, you can do it for anion also, where you are going to put mu minus in the numerator. Mobility of the ion or ionic mobility can be calculated by the formula ionic velocity divided by potential gradient. The unit of that is written over here. Ionic velocity will be in meter per second, whereas potential gradient will be in volt per meter. Now let's talk about conductometric titration curves. So depending upon the strength of acid and base, there can be 4 types of titration curve. Let's talk about the titration curve of a strong acid. The strong acid with weak base is represented by the black line over here. So it is going to show you a sharp like equivalence point, whereas if you are taking titration of strong acid with weak base, so you will be representing it with this red line. So you won't be having a sharp equivalence point, but the graph is going to become flat after that. Example of both of them are given to you. Next we have titration of weak acid. Let's say we are titrating with weak acid with a strong base. So that is represented by this black line over here, whereas titration of weak acid with weak base is represented by this red line over here. Examples are again represented here. Let's talk about cell. So there are 2 types of cells, electrochemical cell and electrolytic cells. Okay, what happens in the electrochemical cell? That it produces electrical energy, okay, through the spontaneous chemical reaction, whereas in electrolytic cell It is a type of electrochemical cell where electrical energy is used to create chemical reactions. So both are reverse of each other. In electrochemical cell, chemical reactions are producing electric energy, whereas in electrolytic cell, electric energy is producing, or it's helping in a chemical reaction. Chemical energy is converted into electrical energy over here, whereas here electrical energy is converted into chemical energy. It do not need any electrical energy source, whereas for electrolytic cell it needs an electrical energy source from the external. Electrochemical cells are spontaneous chemical reactions, like it takes place through spontaneous chemical reaction, whereas electrolytic reaction or electrolytic cell take place in non-spontaneous chemical cell reactions. Anode is negative and cathode is positive in electrochemical cells, whereas anode is positive and cathode is negative in electrolytic cell. This is very important point. Every one of you should be careful about this. Electrons are passed from anode to cathode in your electrochemical cell, whereas in electrolytic cell, electrons are passed from the battery to the cathode, and then the electrons enter to the anode through the electrolytic solution. Both of these cells are shown over here. So this galvanic cell is an example of electrochemical cell, whereas electrolytic cell is also represented over here. Let's talk about cell potential. So the overall cell potential is the difference of the individual potential of cathode and anode. So E of the cell is E cathode minus E anode. To remember the properties of your electrochemical cell, you can remember this particular word lone, okay, where L stands for left side, O stands for oxidation, A stands for anode, and N stands for negatively charged. So that means on the left hand side there will be anode, on anode oxidation will take place, and the electrode is going to be negatively charged, right? And this is for electrochemical cell. You can see a cell reaction is shown over here. This is a left hand half cell, this is left half cell, it is anode, and here you can see the oxidation is taking place from copper to copper 2 plus. There is a salt bridge in between, and then there is a cathode where it is right half cell, and on this side reduction is taking place, and that's how it is represented. Nernst equation relates EMF of the cell with the temperature and concentration of the cell component. So Nernst equation is written as E of the cell is equals to E naught of the cell minus 2.303 RT upon NF log concentration of product divided by concentration of reactant. Now it is very important to understand how to do Nernst equation related question, because many times people do mistake over here. So there are steps to write Nernst equation. The first step is to see the reaction very carefully. Consider the example of the Daniell cell which is given over here. Here zinc is getting oxidized and copper is getting reduced. You can see very simply, like zinc is getting oxidized, oxidation state is increasing, it is removing electrons, whereas copper is getting reduced because it is accepting electrons, or the oxidation state is decreasing. Now what you have to do after checking out the oxidation and reduction, you have to add both these reactions, okay? So you have to add balance and then add the reaction. So on adding, since the electrons are already balanced, so you don't have to do anything. Let's say if there is a question where the number of electrons are different, in that case you have to balance and then add, okay? So if I add this reaction, on the left hand side I was having zinc, and plus I will get copper 2 plus, whereas on the other side I am going to get Zn plus 2, and along with that I will get copper. Electrons are going to be cancelled if I add both these equations. Now that means that on the product side I have Zn plus 2 plus copper, and on the reactant side I have Zn plus copper plus 2. Now remember that when you are filling in the equation, in the Nernst equation, where I am writing concentration of product divided by concentration of reactant, you don't have to worry about the concentration of the solid ions or solids, okay? So you don't have to consider them, only the ionic concentrations are required. So that's why Zn2 plus will be written on the product side and copper plus 2 in the reactant side. The concentration of copper as such and zinc as such will be ignored or will be equal to 1. Here E naught of cell is equals to the standard reduction potential of copper minus standard reduction potential of zinc. Why? Because this is given by E of the cell, or E naught of the cell is E of cathode, E naught of cathode minus E naught of anode. So that's why, okay? So on cathode we were having copper, that's why we are writing reduction potential of copper here, and on the left hand side, or on the oxidation side, or on the anode side, we were having zinc. So that's why E naught of anode here. Okay, so remember that at equilibrium E of the cell is equals to 0. There is one more relationship which relates Gibbs free energy with the EMF of the cell, and that is equals to delta G naught is equals to minus NFE of the cell, or is equals to minus RT ln K. Okay, so these are the relationship which relates to delta G with these equations. Ionic strength basically talks about that how much strength does the solution has considering the ions itself. So ionic strength is equals to 1 upon 2 sigma, that means the summation of mi zi square. So mi is the concentration of the ion and zi is the charge of the ion. Okay, so m is the molality and z is the charge of that ion. Let's take an example. So the ionic strength of the solution containing 0.008 molar AlCl3 and 0.005 molar KCl. So for AlCl3 it is going to break into Al plus 3 and 3 moles of Cl minus, and the concentrations are written to you, given to you as 0.008 molar. So you just have to multiply with the stoichiometric coefficient over here. So the concentration of Al plus 3 is going to be 0.008 molar, concentration of K plus is okay. Again for KCl also similarly I have like separated it out. Now write down their concentrations, and then the concentrations of the chlorine ion is going to be the sum of this plus this. It has been written over here. Now overall ionic strength is going to be half, and sum of the concentration and Z of aluminum square, plus similarly it goes for the potassium, similarly it goes for the chlorine. For aluminum the charge is plus 3, that's why the Z value is also 3, whereas in the place of potassium and chlorine the Z value are 1. So substituting and solving you are going to get 0.053, that is going to be the ionic strength of the solution. Debye-Huckel limiting law, it is given by lambda d is equals to 1 upon kappa is equals to epsilon naught epsilon r kBt upon 2 Na E square into 1 upon I under root or 1 to the power 1 by 2, where lambda d is Debye length, epsilon naught is permittivity of free space, epsilon r is relative permittivity, Kb is Boltzmann constant, T is the temperature, Na is Avogadro number, E is the charge of electron, and I is the ionic strength. So you can simply say that Debye length is inversely proportional to under root of ionic strength. Rest of the things are constant, right? There is one more equation which is called mean activity coefficient equation, and that is given by log gamma plus minus is equals to minus a z plus z minus should be in the mod under root I. Okay, it should be under root I. So that's the equation which gives you the value of your mean activity coefficient. It's the value of A at 25 degrees Celsius, that is for water, is 0.509. So you can substitute it for water. So your equation becomes like log gamma plus minus is equals to minus 0.509 z plus z minus under root I, or I to the power 1 by 2. You can even represent this ionic strength as I or mu, it doesn't matter. Next, let's talk about Tafel equation. So the Tafel equation is the equation in the electrochemical kinetics relating to the rate of the electrochemical reaction to the over potential. Now in the Tafel equation it can be stated as eta is equals to plus minus a into log base 10 I upon I naught. What are these over here? The plus sign under the exponent refers to an anionic reaction, and the minus sign to the cathodic reaction. So remember, it is reverse here. For anodic reaction it is plus sign, whereas for the cathodic reaction it is minus sign. Eta is called as over potential, A is your Tafel slope, I is your current density, and I naught is exchange current density. There is one more important equation called as Ilkovic equation, and it is given by I max is equals to 607 n d to the power 1 by 2 m to the power 2 by 3 and t to the power 1 by 6 into C. I know it's a big equation, but it is generally used in polarography related questions, and where I max is basically maximum current. The units are generally in microampere. N is the number of electrons which are being taken or given during the course. D is your diffusion coefficient, and the unit should be in centimeter square per second. M is the rate of flow of mercury, and the unit should be milligrams per second. T is the drop time, which should be in second, and C is the concentration of the analyte, which should be in millimoles per liter. So this equation is going to be used when a question related to polarography is being asked, right? The next is some application of Nernst equation. So overall potential can be calculated by this formula, that is E of cell is equals to 0.0592 volt into pH plus E reference. Now this rearranges to a particular equation which gives you pH is equals to E of cell minus E reference divided by 0.0592 volt is equals to pH. So if you want to calculate the pH of a particular reaction, of a particular electrochemical reaction, you can calculate it using this particular Nernst equation. For the glass electrode, the equation is given by this, that is Ag plus Cl minus gives you AgCl plus 1 electron. The standard EMF for this is minus 0.22 volt. Whereas for the calomel electrode, the cell reaction is Hg2Cl2 plus 2 electron gives 2 Hg plus 2 Cl minus, and the EMF, standard reduction EMF, is 0.28 volt. So these are very important cell reactions which you should remember, because generally in question they are not given. If you remember it, it becomes easy for you to solve questions. Standard hydrogen electrode is the electrode which is used to determine the EMF of other electrodes. So the standard electrode, or the standard hydrogen electrode, denoted as SHE, standard hydrogen electrode, has a EMF of 0. Okay, so the EMF is considered to be 0. The cell reaction is like H plus taking up 2 electrons to give you half mole of H2. The Nernst equation is E is equals to 0, because the E naught is 0 over here, minus 0.059 log 1 upon H plus ion, or it can be simply written as that E is equals to minus 0.059 into pH of the reaction. Now, if it is connected to NHE as a reference electrode, then the EMF of the cell becomes E of the cell is equals to 0 minus 0.059 of the pH, and that is going to become something like this. So the pH of the reaction can be simply calculated. If you know the EMF, you can just divide the EMF by 0.059, and that is going to simply give you the pH of the standard hydrogen electrode. Now let's talk about concentration cells. So the concentration cells, the EMF arises because of the difference in the concentration of the species involved. Concentration cells are of two types. One is electrode concentration cell, and the other one is electrolyte concentration cell. Electrolyte concentration cell are of two types: concentration cell without transference, and the other one is concentration cells with transference. Now let's talk about concentration cells without transference. So the overall reaction of the combined cell for the passage of 1 Faraday of electricity will be obtained as HCl. Let's say A1 and A2 are the activities on both the sides of the concentration cell. So the EMF of such cell is given as E is equals to RT upon F ln A2 upon A1. Now remember one thing, that here this is for without transference, and one more important thing, that for concentration cells, the value of E of cell is equals to 0. Okay, E naught of cell is equals to 0. So remember that for equilibrium reactions, or for equilibrium conditions, we were having E of cell is equals to 0, whereas for the concentration cells, E naught of cell is equals to 0. All right, that means the standard reduction potential of the cell is equals to 0. Let's talk about concentration cells with transference. So since we know that transport number of cation is equals to 1 minus transport number of anion, hence there can be changes which can be made in this equation, and that is going to just give you a resulting equation of this type. Basically at the end what you are going to get is E is equals to 2T minus RT upon F ln A2 by A1. So these should be in the same line, just to remove your confusion, that E is equals to 2T minus and RT upon F ln A2 by A1. That's the formula to calculate EMF of a concentration cell with transference, where T minus is the transport number of the anion. Liquid junction potential. So if you have a liquid junction potential in the cell, that means that will be in the concentration cells with transference. So for that you just have to take the difference between the with transference minus without transference. Okay, so EMF with transference minus EMF without transference will give you the EMF of the liquid junction potential. Okay, so EL is the potential of the liquid junction. So that is just going to give you the formula. So I'll just write down here. So liquid junction potential can be written as T minus minus T plus and into RT upon F ln A2 by A1. So A2, A1 are activities on both the sides of concentration cells. T minus T plus are the transport numbers of anion and cations. R is a gas constant, T is the temperature, F is the Faraday constant. Alright, so these were the important things from your electrochemistry. Most of the important things which are generally asked in exam has been covered in this particular video. I hope you understood most of the things. The formula has been given in such a way so that you remember them for a longer time, and it just gives you a quick revision of all the important formula from the chapter. I hope you guys like this. That's it for this video, guys. Thank you so much for watching, and I will see you guys in the next one. Till then, have a great day. Bye bye. Take care. Hey guys, so I teach live on Uncademy Plus platform. Here I teach for the CSIR UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Uncademy Plus subscription. So do make sure that you take the Uncademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Uncademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.